Hi, I'm Matthew Williams. I'm a field CTO at Cornelis.
And I'm David Kanter. I'm one of the founders of ML Commons, and where I lead MLPerf, the industry standard benchmarks for AI training and inference.
Can you tell us a little bit more about ML Commons, MLPerf, your core mission, what it's all about?
Yeah, absolutely. So ML Commons is a nonprofit industry consortium. We've got over 125 members from industry, academia, and probably thousands of individuals spread across 6 out of the 7 continents. I always like to say I'm looking for folks in Antarctica because 6 out of 7 is good, but you know, I am a type A kind of guy.
Nice.
And our goal is making AI better for everyone. And that means we want AI to be faster, more capable, more energy efficient, safer, more accurate. And so MLPerf is the vehicle for those ambitions in the context of how do we increase capabilities and increase energy efficiency. And so I got started, I was the secretary for the MLPerf project, and I got promoted to help build the organization and built it up to 20 people. And now I get to focus on MLPerf and how we can, you know, bring these kind of magical AI capabilities all around us in everyday life. How can we make more of those magical moments happen?
Well, I have to tell you, ML Commons is such a common thing.
Yeah.
And especially MLPerf around how people decide to purchase infrastructure. Having that standard way of testing things, reproducible, and especially sharing of data, I think is very key to the industry. So thank you, and congratulations on a promotion.
Yeah, my pleasure, absolutely. And, you know, I often say that, like, you know, a good benchmark, the point of it is to bring everyone together. And, you know, benchmarks are not perfectly accurate. They're never perfect tools. And so you don't get to go true north, but you might be going 6 degrees off of north. But if you bring the whole industry with you, you go tremendously fast. And, you know, in today's era of AI, like that speed, that flexibility is really what we need.
Yeah, oh, for sure. So what are the key bottlenecks you're seeing in sort of the AI infrastructure fields that are limiting the adoption of AI? I mean, you're obviously very familiar with how to test the elements of AI, but as an overall system, what do you see as sort of bottlenecks there?
Yeah, so I mean, I think one of your first call outs is really on point, which is AI is a full system problem. And it is everything from at the lowest level, like what is the transistors that we're using, what is the packaging we're using, to how did we sort the data, to what software algorithms, to the networking, to the scale. And so you can see different bottlenecks coming up at all different places. You know, training on a single node will look wildly different than training on 10,000 accelerators, right? The larger your system gets, the more challenging, for instance, the networking becomes. And we see changes in modality where your data types might vary depending on your use case. We also see things emerging, you know, very rapidly. I think inference shifted to becoming, you know, the first, second, and third thought in some ways. And now people are exploring how can we use storage, how can we use networking to pair with the compute to handle the inference challenges.
Makes a lot of sense. So, you know, obviously Cornelis is a networking company, and we believe, you know, we're the network AI has been waiting for just due to our history of knowing how to do high performance. What are sort of the gaps in network performance testing in the AI industry, and what would it look like as a model to generate this kind of collaborative data to help people compare?
So, you know, for us, and of course I'll speak about MLPerf, our benchmarks do include networking to a certain extent, right? Which is that when you look at MLPerf training, that for at-scale submissions absolutely includes the network. And so, you know, how your performance on primitives works, how fast the network is, what the topology is, all that really matters. And as you do disaggregated inference, that will show up as well. Yeah. But, and those are great because they capture a slice of the at-scale real-world experience, right? And, you know, I think, you know, 5-10 years ago, you would see people talking about benchmarks that focused on, oh, how many packets can I send across a link or maybe through the switch? And that's just really a microcosm, right? But the real world is messy. And the real world at scale is super messy. And so, you know, in reality, some people do run just one training job on a cluster, but a lot of times you'll have multiple training jobs that are co-resident. even within a training job, you're going to see multiple conflicting network flows where maybe one set of nodes is doing a broadcast, another is doing a reduction, someone else is backing things up. And then in the real messy world, you know, if you're running 10,000 processors, some of them are going to fail at any point in time. And so then you're egressing that, restoring it, and capturing that behavior is super hard. And so, you know, some of the things that I think could be very interesting are how do we capture more of that realism, and also in a context where maybe you don't need all of the compute present, so you can study the network on its own.
That messiness, I mean, it's the life Cornelis has lived for the last sort of decade in HPC. You typically don't have a single job on your 10,000 nodes. You have 1,000 jobs, all taking different parts, all doing storage, doing different kinds of communication. And I mean, the fundamentals of Cornelis are about dealing with the mess, making sure that applications run as expected. And again, we believe AI as well is a very messy environment, especially with the heterogeneity that you're going to see in environments. And looking forward to working together on figuring out how to do that network performance element. Now, organizations are looking to future-proof AI, and that's, you know, a challenging statement. But the core infrastructure itself, what are the things they should be looking out for as they, you know, navigate the messy world of the choices that are coming onto market?
Yeah. I mean, I'd say one of the things I have to confess is, like many people, my crystal ball is cloudy, and the speed of AI is intimidating. And so one of the things I often say is it's important to go in and understand what you're looking at. Like, what are your most pressing workloads? Like, maybe you're a retail institution and the most pressing thing is getting recommendations so you can help connect buyers with products more readily. You know, knowing and understanding that, but also maintaining the right level of flexibility. You know, I think one of the things that outside of the field has been just astonishing is how you know, ChatGPT in some sense unlocked like just a totally different paradigm. And even within the world of large language models, things change so rapidly. And then we start thinking about incorporating new types of data, whether it's images or video. Yeah. And so there's an aspect of, you know, absolutely, you know, you should spec out what you want to buy. You know, MLPerf is a great tool to help understand what workloads am I looking for? How can I help establish the performance of what I want? But also keep in mind that things are going to change. And as they do, you're going to want a bit of flexibility to handle that.
Oh, makes sense. So people want to learn more about ML Commons and MLPerf in particular. Where should they go on the web to find out?
Best place to go is MLCommons.org. And, you know, we've got blog posts about benchmark releases, what's in the benchmarks, and, you know, we get to give talks from time to time and work with collaborators.
Excellent. Well, thank you very much. Appreciate your time.
Absolutely. Thank you.